Hi everyone, in this second video on integrating powers of sine and cosine, we're going to be seeing how to integrate cosine of x raised to the power of 4 as well as sine of x raised to the power of 4. And to be clear, this follows my first video on this topic, in which we saw how to integrate sine squared of x, cosine squared of x, sine cubed of x, and cosine cubed of x. So if you're unsure of how to integrate either one of those, I would suggest starting by watching that video. That being said, let's get started. Here we need to integrate cosine of x raised to the power of 4. And it's important to notice here that the power of 4 is an even power. And as soon as we have an even power of either cosine or sine, the trick is to make use of the formula that we have in the upper right hand corner of the screen here. That is the formula for cosine of 2x. Indeed, thanks to this result, in particular the last two lines here, we'll be able to rewrite any cosine squared of x or any sine squared of x in terms of cosine of 2x, which we'll then be able to integrate. So for this integral, here's the trick. I'll start by rewriting this as the integral of, in parentheses, cosine squared of x squared. And now that that's done, the trick is to rewrite this cosine squared of x in terms of cosine of 2x using the second result we have here. And here's what I mean. Using that second line here, we can write cosine of 2x equals to 2 times cosine squared of x minus 1. And now we rearrange this to make cosine squared of x the subject. So if I do that in steps, first I'll have cosine of 2x plus 1 equals to 2 times cosine squared of x. And now if I divide both sides by 2, we'll have 1/2 of cosine of 2x plus 1 equals to cosine squared of x. In other words, cosine squared of x is equal to 1/2 times, in parentheses, cosine of 2x plus 1. Okay, that's the result we're going to be using here, and I want to say that it's the result we'll be using as soon as we're integrating an even power of cosine. So, replacing this cosine squared of x by the expression we have here, our integral can be rewritten as the integral of, in parentheses, 1/2 times, in parentheses, cosine of 2x plus 1. I close all of those parentheses, and all of that's raised to the power of 2. So remember, all I've done is replace this cosine squared of x by the expression we have over here. Now that that's done, this power of 2 will distribute onto both this 1/2 at the front, as well as this pair of parentheses. So this becomes the integral of 1 over 2 raised to the power of 2, which is 1 over 4, times cosine of 2x plus 1, and all that's in parentheses squared. And of course I have my dx at the end here. Okay, now we don't have to do this, but I always like to take this factor of 1 over 4 outside of the integral. So this becomes 1/4 times the integral of cosine of 2x plus 1 squared. And now, using our knowledge of perfect squares for this cosine of 2x plus 1 raised to the power of 2, we can carry on and state that this equals to 1/4 times the integral of, in parentheses, cosine squared of 2x plus 2 times cosine of 2x times 1, which I don't really need to write, plus 1 squared, which is just 1. And still dx at the end here. Now, looking at the three terms we now have, we can definitely integrate the last two we have here, the 2 cosine 2x as well as the 1, but we still have a cosine squared of 2x here. And so the idea for this cosine squared of 2x is to make use of this result again, but now because we have a 2x inside the cosine squared, we'll have a 4x inside our cosine. And so copying this result, but replacing 2x by 4x, and so copying this result with 4x instead of 2x, this becomes 1/4 of, in parentheses, 1/2 of cosine of 4x plus 1, close parentheses, plus 2 cosine of 2x plus 1, and dx at the end. We're nearly there. I now distribute this 1/2 across this pair of parentheses, so that this becomes 1/4 of, in parentheses, 1 half of cosine of 4x. Let me quickly write that. That's 1 half of cosine of 4x plus 1 half times 1. So that's just 1 half plus 2 cosine of 2x plus 1. I carry on and add this half to the 1 to make 3 halves, or 3 over 2. And so this is equal to 1/4 of the integral of 1 half of cosine of 4x plus 2 times cosine of 2x plus 3 over 2. And now we finally reach the stage where we can integrate. And so let me shrink this down a tiny bit to make a bit of space. There we go. And now we integrate. So this is equal to 1/4 times, in parentheses, 1 half times the integral of cosine of 4x. So that's 1 half times the integral of cosine of 4x, which is 1/4 times sine of 4x, plus 2 times the integral of cosine of 2x, which will be 1 over 2, or 1 half, times sine of 2x. And of course we add to that the integral of 3 over 2, which is 3 over 2x. And we'll have a constant of integration at the end here, which I'll call c star for now. And I close that pair of parentheses. And all we have to do now is distribute this 1 over 4 onto each of the terms that we have inside this pair of parentheses. So this becomes 1 over 4 times 1 over 2 times 1/4 times sine of 4x. And let's see, 1 over 4 times 1 over 2 times 1 over 4, well, that's equal to 1 over 32, so that's 1 over 32 sine of 4x, plus 1 over 4 times 2 times 1 half of sine of 2x. Well, this 2 times 1 over 2 cancel each other out, so we'll just have 1 over 4 times sine of 2x, so that's 1/4 of sine of 2x, and we add to that 1 over 4 times 3 over 2x, which turns into 3/8 of x. And finally, we have 1 over 4 times this constant of integration, so that's plus 1/4 of c star. And now to make things more convenient, I'll go ahead and rename this 1 over 4 c star as c. In other words, I'll just let c equal to 1/4 of c star. And so with that in mind, I'll go ahead and state the final answer as the integral of cosine of x raised to the power of 4 is equal to 1 over 32 times sine of 4x plus 1/4 of sine of 2x plus 3/8 of x plus our constant of integration c. And there we go. We've just integrated cosine of x raised to the power of 4. Indeed, we'll be making use of the double angle formula for cosine again, but this time we'll be using the third row. So to finish this video, let's see how to do that. Here we are. We need to integrate sine of x raised to the power of 4. In fact, if you feel up for it, go ahead and press pause and use the method that we just used for cosine of x raised to the power of 4 to try and integrate this on your own. Either way though, let's get started. Mimicking what we did for cosine of x raised to the power of 4, I'll go ahead and rewrite this as the integral of sine of x squared, or sine squared of x, squared. Now that that's done, I'll go ahead and rewrite this sine squared of x in terms of cosine of 2x. And I'll do that using the third line we have here. In other words, I'll go ahead and rearrange the following, cosine of 2x, which equals to 1 minus 2 sine squared of x, in such a way that sine squared of x is the subject. So let's see, I can rewrite this as 2 times sine squared of x equals to 1 minus cosine of 2x, and dividing both sides by 2, this becomes sine squared of x equals to 1 over 2 times, in parentheses, 1 minus cosine of 2x. And I'll go ahead and box that result. There we go. This result is what we'll use as soon as we have to integrate an even power of sine. And so with this, I go back to the integral we have here, and I'll replace the sine squared of x we see by the expression we have here. So this integral becomes the integral of, in parentheses, 1 half of, in parentheses, 1 minus cosine of 2x I close all the parentheses, and I raise that to the power of 2. Now this power of 2 will distribute onto both the half that we have at the front here, as well as this pair of parentheses. So this becomes the integral of 1/2 squared, which is 1/4, or 1 over 4, times 1 minus cosine of 2x squared. And again, I've got my dx at the end here. And just as I did in the previous example, I'll take this factor of 1/4 outside of the integral, and I'll use my knowledge of perfect squares to write all the terms in the expansion of 1 minus cosine of 2x squared. So this becomes 1 over 4, or 1/4, of the integral of 1 squared, so that's 1, minus 2 times 1 times cosine of 2x, so that's minus 2 times cosine of 2x, plus cosine squared of 2x. And I close that pair of parentheses and dx at the end. And now looking at the 3 terms we have to integrate here, it's clear that we know how to integrate the first 2, but for this last term here, this cosine squared of 2x, we're going to have to make use of the double angle formula again. And since it's a cosine squared of 2x, we'll make use of the second line we have here. Indeed, using it, we can go ahead and state that cosine of 2x is equal to 2 times cosine squared of x minus 1. And now rearranging this to make cosine squared of x the subject, we'll have cosine of 2x plus 1, which equals to 2 times cosine squared of x. And dividing both sides of this by 2, we have 1/2 of cosine of 2x plus 1 equals to cosine squared of x. In other words, cosine squared of x is equal to 1/2 of cosine of 2x plus 1. There we go. But now looking at what we have here, we have cosine squared of 2x. And so although we're going to be using this formula, which is for cosine squared of x, because we have cosine squared of 2x, this will become cosine squared of 2x equals to 1/2 of cosine of 4x plus 1. In other words, we now replace this cosine squared of 2x by 1/2 times cosine of 4x plus 1. And so our integral becomes 1/4 of the integral of 1 minus 2 cosine of 2x plus 1/2 times cosine of 4x plus 1. And I close the pair of parentheses and dx at the end. Okay, tidying this up a bit by distributing this half across this pair of parentheses, this becomes 1/4 of the integral of 1 minus 2 cosine of 2x plus 1/2 of cosine of 4x plus 1/2. And now adding the 1 we have at the front here to the half we have at the end, this becomes 1/4 times the integral of 1 plus 1/2, which is 3/2, or 3 over 2, minus 2 times cosine of 2x plus 1/2 of cosine of 4x. There we go. And at this stage, we're ready to integrate. So let's go ahead. This is equal to 1/4, or 1 over 4, times, in a pair of parentheses, the integral of 3 over 2, which will be 3/2 of x, minus 2 times, since we have a 2 here, the integral of cosine of 2x. And the integral of cosine of 2x, well, that's 1 over 2 times sine of 2x. I carry on and add to that 1/2 of, since we have this 1/2 here, the integral of cosine of 4x. And the integral of cosine of 4x, well, that's 1 over 4 times sine of 4x. And at the very end here, we add a constant of integration, which I'll call c star. And I close that big pair of parentheses. We're nearly there. All we have to do now is distribute this 1 over 4 to each of the terms we have inside this pair of parentheses. So let's see, we have 1 over 4 times 3 over 2x. So that will be 3 over 8x minus 1 over 4 times 2 times 1/2 of sine of 2x. Well, this 2 times 1/2, that's just equal to 1. So we have 1 over 4 times 1 times sine of 2x. So that's 1 over 4, or 1/4 of sine of 2x, plus 1 over 4 times 1 over 2 times 1/4 of sine of 4x. And let's see, 1 over 4 times 1 over 2 is 1 over 8, times 1 over 4 is 1 over 32. So we have plus 1 over 32 times sine of 4x. And finally, we add to that 1 over 4 times this c star. So I'll quickly write that. That's 1 over 4 times c star. And as I always do, I'll go ahead and define a new constant, c, which is equal to 1/4 of that c star. And so shrinking this just a bit to write my final answer here, we can go ahead and state that the integral of sine of x raised to the power of 4 is equal to 3/8 of x minus 1/4 of sine of 2x plus 1 over 32 times sine of 4x plus a constant c. And we're done. We've now integrated sine of x raised to the power of 4. And there we go. That's it for this second video on integrating powers of sine and cosine. And hopefully, thanks to this video, we now have a good understanding of the fact that when integrating even powers of sine or cosine, we need to make use of the double angle formula for cosine. And in fact, if instead of a power of 4 here we had a power of 6, 8, or 10, then again we'd make use of this double angle formula. There we go everyone, I really hope that helped, and if it did, please hit like on this video, drop a comment down below, and even subscribe to this channel to help get this video to as many students as possible. All that being said and done, that's it for this tutorial.